This lesson will prepare you for section 9.2 in your book, and it's going to show you the basics of graphing quadratic equations. So let's start by reviewing some graphing we've already done. We've already this year graphed linear equations, and here's an example of a linear equation. The way we went about graphing this is to first notice that this point right here is always the y-intercept. So 1, 2, 3, 4, 5, 6, 7, 8. And the reason that's the y-intercept is that if you plug in 0 for x, 8 minus 2 times 0, well, you get 8 for y. So 0, 8 is on the graph. Then we used this number, the negative 2. That was our slope. So best to think of it as a fraction, negative 2 over 1, which means go down 2 over 1, down 2 over 1, and so on. The more points you draw, the easier it is to sketch your line accurately. Okay, so that's a review of graphing linear equations. What we're now going to move on to is how do you graph a quadratic equation? So we're going to start with the most basic quadratic equation that there is, y equals x squared. It's quadratic because the variable x is squared, and that's what we call quadratic. So here's a table that will help us graph this. So let's think about what the y values would be for these x values. If you plug in a negative 3 for x and square it, well, negative 3 times negative 3 is positive 9. If we plug in a negative 2 for x, squaring negative 2 gives us 4, squaring negative 1 gives us 1, 0 squared is 0, 1 times 1 is 1, 2 times 2 is 4, and 3 times 3 is 9. So that means the points that we need to graph are negative 3, 9, negative 2, 4, and so on. So let's see if I can find those points here somewhere. There they are. So those are the 1, 2, 3, 4, 5, 6, 7 points. And then once you have those points, you can connect them, which is hard to do on my tablet here, but I'll do the best I can. And you get this U-shaped graph. That shape is called a parabola. And some features to notice about the parabola. This point right down here is called the vertex. That's where it turns around. And also notice that a parabola is always symmetric. In this case, your line of symmetry is right there. Cuts the parabola into two halves. And in this particular example, the equation of that line is x equals 0. It's a vertical line at x equals 0. Okay, so that is the most basic quadratic equation, y equals x squared. That's what its graph looks like, and I suggest you kind of remember that. Just sort of remember what the graph of y equals x squared looks like, because all quadratic equations are based on that. So you want to get that firm in your head. Alright, let's look at another quadratic equation. I went ahead here and already filled in the table, but just so that you can see where these values are coming from, suppose I look at this row on the chart. How did I know that when x is 5, y is negative 3? Well, you plug in a 5 for x, 5 squared minus 8 times 5 plus 12. Or 25 minus 40 plus 12. Or let's see, 25 minus 40 is negative 15 plus 12 is negative 3. So that's how we got that particular pair of numbers. I'm not going to take the time to go through the rest of them here. If we now go ahead and graph all these points, see if I can find it here somewhere. I have these points. There they are. So that's what they look like. And then I can go ahead again and connect those with this familiar shape called a parabola. Okay, so let's think a little bit about this parabola. I'm going to go ahead and get rid of this just so that we have some space to work, and erase this. Okay, so now let's think a little bit about this parabola. Its vertex is right here, and the coordinates are 1, 2, 3, 4, comma 1, 2, 3, 4, but it's down 4, so 4, negative 4. There's another really interesting or important feature of the graph, and it's called the roots. And the roots are these points right here where it crosses the x-axis. In this case, it crosses the x-axis at positive 2, and let's see, 1, 2, 3, 4, 5, and positive 6. And in general, if you know where the roots are, that can help you to locate the vertex, because the vertex is always on the line of symmetry, and the line of symmetry that cuts the parabola in half, sorry this isn't a little bit neater, is always, the vertex is always on that axis of symmetry. In this case, that's x equals 4. And that 4 is always going to be the average of your roots. It's halfway between 2 and 6. So you can average them by adding them and splitting in half. And then once you know the x-coordinate of the vertex, if you need the y-coordinate, you can plug in this case, 4 for x. 4 squared minus 8 times 4 plus 12. And if you compute that out, you'll get negative 4, the coordinates of the vertex. Okay, here's another trick. The book doesn't show you this one, but another way of finding the vertex, instead of averaging the x-coordinates, there's a result that you might learn later. It's really not in your algebra textbook, but it turns out that if you take this number, negative 8, over 2 times this number, which in this case is an invisible coefficient of 1, the opposite of this number, so positive 8, you get the 4 also. I don't know if that'll help you or not, but you can average the roots, or you can take the opposite of this number divided by twice that number. Either way, you'll get the 4. Okay, that was a lot of information. Hope it made sense. For your homework, graph y equals x squared plus x minus 6 on your calculator first. Then sketch that graph onto a piece of graph paper. Find the roots, find the coordinates of the vertex, and then write the equation in vertex form. Okay, I'm realizing I didn't show you vertex form, so let me go back here. Oops, that's kind of messy. Clear that out, erase all this, and now I'm going to show you how you can write in vertex form. Okay, this is possibly going to seem a little mysterious, so I'm just going to ask you to follow the example. And the more you study algebra, the more this will become clear to you. But vertex form looks like this. Y equals x minus h squared plus k, where the vertex is h comma k. So since we know the vertex is 4, negative 4, 4 is h, negative 4 is k. So here it is in vertex form. X minus h is 4, squared, plus k. And k is negative 4, so I'm going to write minus 4. So that's how you write it in vertex form. Please notice that there's a minus here, so you're actually going to minus whatever your x-coordinate is. Okay, here the x-coordinate was 4, so we subtracted 4. But then it's plus k, so you're actually going to, again, subtract this time because k was negative. Okay, so again, back to your homework. Please have that ready for class next time.